So let's move on and let me show you guys why the daylight in these three places at once debunks the AE map. So here's Tasmania, here's Cape Town, and here's Ushuaia. Now here's the portion of the Earth that's nighttime. How can it be light right now in Tasmania, light right now in Ushuaia, but not in the North Pole? How can it be light here, but be dark right here?
The refraction of light can create many beautiful optical illusions. Suppose we change the shape of this lens. Let's now return to our original shape. Suppose we change the location of the objects. The image can either be right side up or be inverted upside down. A beam of light is composed of particles called photons. Photons are very different from the particles that matter is made out of. When a wave enters or exits a material at an angle, the left side and the right side of the wave will cross the boundary at different times. The greater the angle, the greater the difference in time when the left side and right side of the wave change their speed. This causes the wave as a whole to change direction both when it enters and when it exits the material. Parallel beams of light passing through this lens will exit moving away from each other. If we trace their paths backwards as straight lines, then the location where these lines meet is what we call this lens's focal point. Parallel beams of light passing through this other type of lens will exit moving towards each other. In this case, we call the focal point the place where their paths meet. This is what will happen if a beam of light enters a material where its speed is much slower. If a beam of light tries to exit such a material at a sufficiently large angle, it will turn around completely and 100% of the light will be reflected. With the exception of the second law of thermodynamics, almost all the laws of physics work the same way backwards in time as they do forwards in time. This means that if our beam of light reverses directions, it will follow the exact same path as before. Time symmetry also means that in the case of reflection, The beam of light comes in at the exact same angle that it reflects. This is because if the two angles were not equal, it would not work the same way backwards in time as it does forwards in time. Whenever a beam of light passes a boundary where its speed changes, at least some of the photons will always be reflected, even if many of the photons pass through. The reason for this, and the reason for all the other phenomena discussed, is due to the fact that refraction is a characteristic of all wave propagation in general.